Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we will be solving problems based on the relationship that we derived between the coefficients and the zeros of a polynomial in the last video. So if you haven't watched that video, I request you to watch it before watching this video. Link of that video would be put up in the description box. Now let's start. The question says that verify the relationship between the zeros and the coefficients of the given polynomials. Before solving the problem, let's just revise what we have done. So here if you see, we all know that the sum of the zeros of a quadratic polynomial is always equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square, and the product of the zeros is c by a, where c is the constant term and a is again the coefficient of x square of the quadratic polynomial, which is of the form ax square plus bx plus c. Now whenever in exam you have been given such type of questions where you are given a quadratic polynomial and you are asked to verify the relationship between the coefficients and the zeros of the polynomial, you have to follow a step-by-step approach. It's a four-step process which you need to follow. In some problems, all the four steps would be utilized. Otherwise, in some problems, you don't have to utilize all the four steps because of the nature of the problem. So let's start. So I would just read out the steps, then we are going to use the steps that are there on the board to solve these two problems. So if you see, the first step would be rearranging in the standard format, meaning whatever the equation is given to you. I'm so sorry, whatever the expression is given to you, the quadratic expression, you have to see it and you have to compare it with the standard format. Now this is the standard format, which is ax square plus bx plus c equals to 0. Now you need to arrange the given question in the standard format such that your x square would be first, your x would be second, and followed by your constant term. So that is your step number 1. Let's say if in any problem already the given question is in standard form, then you don't have to do the step 1, you can directly move on to step number 2. Now step number 2 remains the same for any kind of problem, that is you need to factorize the given polynomial. Now why do you factorize? We factorize because in order to get the values for the zeros of the polynomial, and we did see in the last video how exactly the factorization gives us these zeros. Then step number 3 is you have to use the zero product property to get x value. Now what is the zero product property? You might not have heard about it, but you have often used it in the factorization problem. So we will see what exactly is zero product property and where you have been using it since your previous standards. Then finally, after getting the values for x or value for x, you are going to verify the equations. Once you have got, since it is a quadratic equation, of course there would be two zeros. So once you have got the values for both the zeros, you are supposed to substitute the values in these two equations and you have to see whether the LHS is equal to the RHS of both the equations. So step 1 is to rearrange in the standard form. Step number 2 is to factorize. Step number 3 is to use the zero product property to get the value of x. And finally, in step number 4, you are going to verify the relation. Now, you will verify the relation only if you are having the values for x. That is, only if you are having the values for the zeros. That is why in the first 3 steps, we would be calculating the values for the zeros of the polynomial, and then we would be using the equations that we have learned in the last class to verify the relationship between the coefficients of the polynomial and the zeros of that polynomial expression. Now let's start. The first question is 6x square minus 3 minus 7x. So I want you all to observe this and conclude whether this is in the standard form or not. So if you compare it with the standard form, as I have told you, the powers of the variables are always in the descending order, that is from the highest power to the lowest power, and the constant term would be at the last. And this is not true for quadratic polynomial, it is true for any polynomial of any degree, right? So here clearly if you see, yes, the first term is x square, but now we have to interchange these two terms along with their signs, right? So now step number 1, rearrange. Again, the steps that I'm writing with red pen, they are for your understanding. You're not supposed to write them in the solutions. When you're writing your problems, you're not supposed to mention them in your solutions. So when you rearrange, the question becomes 6x square minus 7x minus 3. So now if you see, this is in line with the standard format. Now what is the standard format? It is ax square plus bx plus c, right? So if you compare this, they are both in the same format. Now step number 2, if you read step number 2, it says factorize to get the zeros of the polynomial. So step number 2 for every problem would be factorization. So factorization of polynomial. Okay, so when I factorize this, now in order to factorize, what I'll be doing is I'll be splitting the middle term. Now if you see the middle term in this case, if it is, you have to pay special attention as to what is the sign of the middle term and consider the middle term along with its sign. So here if you see, the middle term is minus 7x, right? So minus 7 is the middle number, and you have to split it in two parts such that when you add those two numbers you would get minus 7, and when you multiply those two numbers you would get product of 6 and 3. So first of all, what is product of 6 and 3? It's 18. Now 18 comes in the table of 2, it comes in the table of 3, it comes in the table of 6, 9, etc, etc. So now the factors, or you would say the splitting of this middle term would be such that, can I write it as minus 9 plus 2? Yes, of course I can write it like this, because minus 9 into plus 2 will give you minus 18, and here if you see 6 into minus 3 is also minus 18, right? And minus 9 plus 2 would give you minus 7. So you are going to write the middle term as minus 9x plus 2x minus 3. So this is how. Okay, now from these two terms you are going to take 3x common. When you take 3x common, the term that is left over here is 2x, and the term that is left over here is 3. This is pretty simple. Here if you see, if you take 3x common, so 3 2s are 6, and you take 1x common, so 1x remains. From here, from 9, if you try to take its multiple outside, that is 3, inside the bracket 3 would be left and the x comes outside. Similarly, in these two terms, if you see, there is nothing common. If there is nothing common, then you are supposed to take 1 as the common term. So you are going to take plus 1 as the common, 2x minus 3. Now, if you see, this and these terms are same, so you're going to take it common. So if you take 2x minus 3 as common, so inside the bracket remains 3x and plus 1. So we get 3x plus 1. So this is where your step 2 ends. What is step 2? Factorization of the polynomial. Now let's move on to step number 3, which says that use the zero product property to get x value. Now what is the zero product property? I will again tell you that you have been using this property since you have been doing factorization problem. It's just that maybe some of you know it, maybe some of you don't know it. You're not supposed to mention it in the exam, but you need to know the general terminology that this property is known as. So step number 3 is using zero product property. Now what is the zero product property? Now here if you see, any equation is equal to 0. You want to find the values for x, right? So any equation is equal to 0, or you can say the product of any two terms. Let's say you have two terms x and y, and you say x into y is equal to 0 only if either your x is equal to 0 or your y is equal to 0. And this is pretty obvious. You would say that there is nothing new in this or there is nothing innovative in this. We know that if you have two random terms and you don't know what are those two terms, but yes, their product is equal to 0, then the possibility is that in order to get the product of these two terms equal to 0, either of them should be equal to 0. Right? So that is why I said that either your x is equals to 0 or your y is equals to 0, both can also be 0. But one term at least should be equal to 0. Now we don't know which term can be 0 because we don't know the values for x and y. So in this case, we say that your x is equals to 0 or y equals to 0. Since we want to find the values for x, that is the solution for this particular polynomial, therefore we say that your 2x minus 3 and 3x plus 1 is equals to 0. This implies that either your 2x minus 3 is equals to 0 or 3x plus 1 is equal to 0. Right? So after doing step number 2, you're going to equate this equation to 0 and you're going to say that this is true when this is equal to 0 or the second term is equal to 0. And this is where your zero product property comes. Here if you see, this is your term 1 and this is your term 2 and both are multiplied. Now if both are multiplied and the product comes out to be 0, it means that either the first term should be equal to 0 or the second term should be equal to 0. Now we are going to take these two equations and get the value for x. That is what your step number 3 says, that you use the property and get the value of x. So this implies that your 2x would be equal to 3 or your 3x would be equal to minus 1. This implies your x would be 3 by 2 or your x would be minus 1 by 3. And these are the two values of x. Right? So these are the two roots, right? So you would say therefore the roots of the polynomial are 3 by 2 and minus 1 by 3. Now we come to the last step, that is step number 4. So step number 4 is verifying. Now whenever you want to verify, you're first going to consider one equation at a time. So we are going to consider the first equation, right? So we are going to say consider alpha plus beta equals to minus b by a. Okay, now take the left hand side. Your left hand side is alpha plus beta. Now what is alpha plus beta in this case? So when you try to add 3 by 2 plus minus 1 by 3, right? So you get 3 by 2 minus 1 by 3, right? Now when you cross multiply, 3 into 3 is 9 and 2 into 1 is 2. 3 into 2 is 6. This is your normal arithmetic operations. So this becomes equal to 7 by 6. So you got alpha plus beta ka value as or LHS as 7 by 6. Now try to calculate RHS. What is your RHS? Minus b by a. If you try to compare minus b by a with this equation, your b in this case is minus 7. Be careful with the signs. Never try to ignore the signs of the term. If it is addition, you don't have to mention it. But if it is subtraction, you have to be very, very careful. So here if you see, instead of a plus sign, there is minus 7. So a b ka value is minus 7 and a ka value, that is coefficient of x square, is 6. So we get it as minus 7. Already a minus sign is there. B is minus 7 upon 6. So that is equal to 7 upon 6. If you see, your LHS is equal to your RHS, right? This implies your alpha plus beta is equal to minus b by a. Okay. Now, similarly, you are going to now consider alpha into beta equals to c by a. Take the LHS. This is your verification step. Okay. So now alpha into beta. Your alpha ka value is 3 by 2 and your beta ka value is minus 1 by 3. 3 in the numerator and 3 in the denominator gets cancelled. So you get alpha into beta is minus 1 by 2. Similarly, take RHS of the relation, which is C by A. If you see the value for C over here is, again be careful with the terms, it is minus 3. And what is your A? It is 6. When you try to reduce this, again you are going to get minus 1 by 2. If you see, you are getting minus 1 by 2 over here, minus 1 by 2 over here. Therefore, your LHS is equal to your RHS. And if your LHS and RHS are equal, it means that alpha into beta equals to C by A. And hence, verified. This was your question, that you need to verify the relationship between the zeros of the polynomial and the coefficient, for which we followed a 4-step approach, in which the first step was rearranging the given polynomial in the standard form, followed by factorization of the polynomial. Once you got the factorized polynomial, that is, once you got the factors, equate it with 0, use the zero product property to say that each factor is equal to 0, and then from here try to get the values of x, which are basically the roots or the solutions or the zeros of the polynomial. Okay, so these are the roots, or you can even write zeros over here. Okay, these terms are interchangeably used. I would suggest write zeros only instead of roots, because the question talks about the relationship between the zeros and the coefficients. Then finally, step number 4, which is actually the demand of the question, that is to verify the relationship between the coefficients and the zeros. So what we do is, we consider the equation, we solve its left hand side, we solve its right hand side, and then we say ki both the values are same, and hence the relation is verified. Right, now let's solve the second problem. I would go a little faster here, and I wouldn't be writing steps now. I would be solving as to how your solution should look like. Okay, so let's see the second question. If you see your second question, it kinds of look different, right? It is a quadratic polynomial, but it doesn't have the constant term, and that's completely fine. And yes, the terms that are there, they are already arranged in the descending order. So here we can skip step number 1. Now we are moving to step number 2, that is factorizing the polynomial. So when you want to factorize the polynomial, what you are supposed to do is, if you see these two terms, do they have anything in common? Whenever you want to establish, a product relation between any two terms, whenever you want to factorize any given expression, I would suggest you try to find any common terms that exist, okay, in the terms. So if you see in 4u square and 8u, first thing that is common is the variable u, and second, between 4 and 8, of course 4 is common, because 4 is multiple of 4 as well as it's a multiple of 8. So I will take 4u common. If I take 4u common, here u remains, and over here 2 remains, right? So 4u and u plus 2 when equal to 0, I equate this with 0 now. Now using the zero product property, I would say that your 4u is equal to 0, or u plus 2 is equal to 0. So here if you see, factorization and even the zero product property was pretty simple, and the solution or reaching to this step was pretty short as compared to this one where you actually had to factorize, right? So from here you get u to be equal to 0 by 4, or your u is equal to minus 2. So your u will be equal to 0, or your u is equals to minus 2. So these are basically the zeros. So the zeros of the given polynomial are 0 and minus 2. So once we get the zeros, that is the values for x, now let's move on to step number 4, that is verification. So we are going to consider, of course, alpha plus beta equals to minus b by a. So your LHS in this case is alpha plus beta, which is equal to, your alpha is 0 and your beta is minus 2. So that is minus 2. Now let's calculate RHS, which is minus b by a. If you compare minus b by a with this equation, if you see, this is your b and this is your A, right? So your B is 8 and your A in this case is 4. 8 when divided by 4 you get equal to minus 2. So your LHS is equal to your RHS. If your LHS is equal to your RHS, it means your alpha plus beta would be equal to minus B by A. Okay, this is the first equation that we have verified. Now similarly, you're going to consider alpha into beta equals to C by A. LHS of this equation is alpha into beta. So that would be 0 into minus 2. Anything multiplied by 0 is 0. Now let's consider the RHS. It's C by A. Do we have a constant term over here? If nothing is there, it means of course there is 0. Because you write 0, you don't write 0. Doesn't matter, right? So your C in this case is 0. Your A in this case is 4 because the coefficient of U square is 4. So answer is 0. So your LHS again in this case is equal to your RHS. And if your LHS is equal to RHS, it means that alpha into beta is equal to C by A. And that is why you can say that you have verified the relationship between the coefficients and the zeros of the given polynomial. So students, in today's class, we started with solving a problem wherein we had to verify the relationship between the coefficient and the zeros of the polynomial. We saw what approach we need to follow. There was this 4-step approach which we are supposed to follow whenever we are solving problems of this type. Okay, this following a step-by-step approach actually helps you to remember the procedure in which you should solve the problem. Okay, so in exam, if at all you get stuck somewhere, you know, yes, step number 2 was factorization. Step number 3 was, now what to do? Step number 3 is equating 0 and getting the values of x. And finally, after getting the values of x, you are supposed to verify it. So whenever you try to, divide the problems into different small steps, it's beneficial for you, so that when you're revising for your exam, you just need to revise the steps, because in mathematics you're not supposed to learn the problems. So instead of learning the problems, which nobody does, I'm sure, you are supposed to learn the steps for solving the problems. That would actually help you to remember the process or the procedure that you are supposed to follow, right? So in today's class, we actually solved problems and we saw this 4-step approach. I hope you all have understood and enjoyed today's class. So thank you so much for staying with me till the end of this video, and see you in the next video. Thank you.